Today we are going to discuss about the band theory and the band structures, mainly the electronic property of the materials. So in that we are going to discuss about the band theory and the band structure. So band theory, the solid state physics, the theoretical model is describing the states of electrons, the solid state material that can have the values of energy only within the certain specific ranges. The behavior of the electrons in solid state, hence its energy, is related to the behavior of all the particulars around it. The conduction and the valence band we have. In between conduction and the valence band, in between the insulator is available. That's the valence band is there. The energy gap is there. So energy band gap is there. So in case in semiconductor, the conduction and the valence band gap is very minimized one. And also the conductor, the valence band gap is very minimum. It's near close to each other. And also the energy band gap, the mainly in the solid state we have the conduction of energy to the nucleus. So the nucleus of the energy will be conducting the conduction band, and also the energy band. The diagram is shows here the conduction of the band and the valence band having the two bands, that's band 1 and band 2. It's also having the forbidden energy gap is also available, it's epsilon naught. In general the energy is represented at the epsilon 0. So the energy of the band gap is increases high, and also the energy band of the diagram and having the valence band have the difference band is available in the valence and the conduction bands. The forbidden energy gap, mainly the gap in between the valence and the conduction band, it is called as a forbidden energy gap. And also the name implies that the band is forbidden one, without energy. So there is no energies available in the gap, like it's a null energy is available. The forbidden energy gap is greater means that the valence band and electrons is tightly bonded in the nucleus. So here we have the valence and the conduction, the gap is high, the forbidden gap. So automatically the electrons move, and the conduction band the gap is high, the full valence band is very difficult to conduct. And also the energy forbidden gap is high in the sense to start conducting of the electron is very highest one. In solid state, we have the atoms are arranged in the systematic space lattice of each atoms and influenced by the neighboring atoms. So once it will be very short one, it will be minimized, and also it's used to the influences. And also the closeness of atoms as a result is intermixing of electrons in the neighboring atoms. Here like this, the atoms are arranged here. So the neighboring atoms also under will be arranged together. So the insulator mainly the forbidden gap is very large, because the conduction band and the valence band gap is high in the sense not able to connect, not able to join. So mainly approximately 3 electron volt number is available. So electron is available in the conduction band. So the large amount of energy is needed to remove the electron from the valence band to conduction band. This is very important. So this is called as a field band conduction band. So once we apply the external energy, the automatically the forbidden gap is decreases. In case of the semiconductor, the forbidden gap energy is very small, and also 0 Kelvin needed to the conduction of band, and also the valence band is completely filled. And semiconductor amount of energy is supplied, and also the electron can easily jump to the forbidden gap. This conductivity of the semiconductor is 10 to there is a ohm meters automatically. And so the conductor is there at the forbidden gap, and also there is no forbidden gap. The valence band and the conduction band is overlap here. So automatically the electrons from the valence band and freely into their conduction band, and also overlap into the bands. Therefore, the very low potential difference between the two bands also causes the continuous flow of current. This is the main important parameter of the conductor. The electrons hold semiconductor. The absolute zero temperature in the process semiconductor's valence band is completely filled out the conduction with the vacant. So this is the electron, this is the conduction band. So it's at 0 Kelvin. So there is no things. The energy gap is there in between. So this will be electron holes in the semiconductor parameter. These electrons and the holes automatically they pair in the room temperature. Some electrons get the energy to broken the covalent band moves into the conduction band. So valence band to conduction band at the room temperature. It's an important parameter of the electron movements. Thank you.